Hello everyone, welcome to our lecture on the mole, which I've subtitled the coolest unit in chemistry, so you know it's going to be good. Okay, so one definition of a mole is a furry little creature that burrows underground. You will no longer think of a mole as just this furry little creature, which I have pictures of here. There's a mole, and here, that's a mole. Furry little creatures living underground. Or you're not you're not going to think of it just as that little black lesion that grows on your skin, like this. Nope. Now you're going to think of a mole as a number. Specifically, that number is 6.02 times 10 to the 23rd. So a mole is a number. And you can kind of think of this as the same way that you think of a dozen as a number. If I say the word dozen to you, you know exactly what I mean. You know it means 12. Now you're going to add to that knowledge, you're going to know that 6.02 times 10 to the 23rd means mole, or mole means 6.02 times 10 to the 23rd, in the same way that a dozen means 12. All right, so let's look into this a little further. The reason we have this at all, the reason we care about this at all, is that atoms and molecules and ions and so on are super, 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 super small. And that means that even in a small sample, half a milligram of a sample will have millions and millions of atoms or molecules in it. So that makes it really difficult to count. The size of an atom, remember, is something like 50 picomolar, or around somewhere times 3 times 10 to the minus 11 meters. So it's small. And when I say small, I mean really small. Okay, and so since the size of an atom is so small and there are so many of them in a given sample, the mole was developed in order to help us count atoms and molecules and so on. So here's our definition. A mole, which is abbreviated MOL, and frankly that's not the most spectacular abbreviation ever since you're really only losing one letter, but whatever. A mole is 6.02 times 10 to the 23rd representative particles, and when I say that, I mean things. 6.02 times 10 to the 23rd things. And a thing can be an ion, or an atom, or a molecule, or a formula unit, but it could also be a grain of sand, or a star in the sky. You can count anything with moles, just like you can count anything with a dozen, right? If I say I have 2 dozen eggs, you know it means 24. It doesn't matter whether I'm counting eggs or donuts. 2 dozen still means 24. Well, the same concept applies here. A mole is just a number of things. So 1 mole is 6.02 times 10 to the 23rd atoms, or 1 mole is 6.02 times 10 to the 23rd molecules, or 1 mole is 6.02 times 10 to the 23rd bananas. It just doesn't matter what you're counting. The mole tells you how many of it you have. This fella here is the one who developed the concept of a mole, and his name is Avogadro, not avocado, like the fruit that you squish into some delightful guacamole, but Avogadro. And Avogadro is the one who gave us the mole, not this mole. And so in fact, this number is also called Avogadro's number. 6.02 times 10 to the 23rd is Avogadro's number. Well, how do we use that? All right, here's how. We can now ask questions like, how many molecules are in 1 mole of a substance like propane? If you know that you have 1 mole, we can now tell how many molecules are in there, because a mole is 6.02 times 10 to the 23rd things, whatever you're counting. In this case, molecules of propane. So 1 mole of propane is 6.02 times 10 to the 23rd molecules of propane. How about this? Here's another question. How many molecules are there in 2 moles of propane? Well, 2 moles of propane times 6.02 times 10 to the 23rd molecules in each mole should give you 1.204 times 10 to the 24th molecules, or this Avogadro's number times 2. Just the same way as if I had asked you how many molecules are in 2 dozen molecules of propane, you would know it's 24 molecules. This is the same idea. Now we can ask trickier questions too, though. How many atoms are in 1 mole of propane? Here. All right. How many atoms are in 1 mole of propane? Well, 1 mole of propane is this many molecules. There are 6.02 times 10 to the 23rd molecules of propane in a mole. But I'm interested in the atoms. A molecule of C3H8, or propane, has how many atoms in it? Well, look at the formula. I see 3 carbons and 8 hydrogens, which means that 1 molecule of propane is 11 atoms altogether. All right, so then 11 atoms in 1 molecule times 6.02 times 10 to the 23rd molecules should give us the number of atoms in a mole of propane. Atoms are in, lost my place there. So we can figure out how many atoms are in a mole of propane by multiplying 11 atoms per molecule times 6.02 times 10 to the 23rd molecules, which equals 6.6 times 10 to the 24th atoms in 1 mole of propane. All right? Make sense? Here are some interesting mole fun facts. You don't need to write these down. They're just interesting to remember, to hear, and hopefully they'll help you get a grip or come to a sense of how big a mole really is. If you had 6.02 times 10 to the 23rd watermelon seeds, you would need a melon slightly larger than the moon. Or if you had 6.02 times 10 to the 23rd donut holes, it would cover the entire planet 5 miles deep. That's a lot of donut holes. If you had 6.02 times 10 to the 23rd pennies, it would make at least 7 stacks of pennies that would reach to the moon. I don't know why you'd want to make stacks of pennies up to the moon, but there you have it. If you had 6.02 times 10 to the 23rd grains of sand, it would be more than all the sand on Miami Beach. If you had a mole, I like this one. If you had a mole of dollars, you could not spend it at the rate of $1 billion a day in over 1 trillion years. So that would be a challenge for even our government to spend. If we were able to count atoms at the rate of 1 million atoms per second, it would still take 2 billion years to count the number of atoms in 1 mole. So a mole is really, 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 really big. Some more facts. If you had 6.02 times 10 to the 23rd blood cells, that's more than the total number of blood cells found in every human on the planet added together. But kind of flip that a little bit. In a liter of water, there are 55 moles of H2O. In a 5-pound bag of sugar, which is sucrose, the formula which is C12H22O11, in 5-pound bag of sugar, there are 6.6 moles of sucrose. There are actually 3 types of moles that live underground in North America. These include the eastern mole, the hairy-tailed mole, and the star-nosed mole. And then there is, of course, my favorite mole, the Mexican mole, which is a chocolate saucer that goes on, for example, enchiladas. Quite wonderful mole. It comes from the Aztec word mole. Okay, well now you know a little more about moles, and you've seen a little bit about how we can use them in calculations, and we'll have a little bit more in the next lecture that you look at. Thank you.